7,982 tons of steel and tungsten carbide, spinning at 1.2 revolutions per minute, 80 feet below the streets of downtown Seattle, and it stopped. Not slowly, not with warning. The temperature gauges spiked, the main bearing seal filled with grit. The cutterhead, nearly a full acre of rotating metal, ground to a halt on the 6th of December, 2013, just 1,028 feet into a planned 9,270-foot journey. The sound, according to workers at the rear of the machine, was like a turbine winding down in slow motion, then silence. For more than 2 years, that is all there was. The machine that was supposed to redefine what civil engineering could do in a major American city had become, instead, the most expensive piece of buried machinery in the history of the Western Hemisphere. And the man who had warned that this exact machine was not powerful enough for these exact soils had already put his warning in writing. In December 2013, after excavating about 10% of the tunnel alignment, crews began to experience difficulties with TBM advancement, leading to an eventual shutdown and a repair plan that idled the machine for about 2 years. About 30 buildings in Seattle's historic Pioneer Square neighborhood had to be inspected both inside and out for damage after the soil deep below slumped an inch from Highway 99 tunnel work. A Pioneer Square building owner asked the state for almost $400,000 for damage and lost income suffered during years of Highway 99 tunnel delays. The city of Seattle claimed that STP, or the state, owed as much as $81 million for potential damage to underground utilities, sidewalks, and streets throughout Pioneer Square. And Seattle Public Utilities had already replaced a cast iron, 2 0-inch diameter water main below Western Avenue after the soil sank 1¼ inches near the tunnel job site. Tunnel boring was halted on the 14th of January 2016 after a 30-foot-wide sinkhole developed on the ground in front of the machine, causing Governor Jay Inslee to halt drilling until the contractors could perform a root cause analysis. That sinkhole measured 35 feet long, 20 feet wide, and 15 feet deep, and required 250 cubic yards of concrete sand mix to fill. Seattle Tunnel Partners, led by Tudor Perini of California and the U.S., arm of Spanish tunneling firm Dragados, filed claims soon after Bertha overheated and stopped digging in late 2013. At the center of those claims was a project manager named Chris Dixon and a buried pipe that nobody could agree was there or there enough to matter. The physical evidence that might have settled that argument vanished, and what replaced it was a decade of litigation that would cost more than the machine itself. Welcome to the SR-99 Highway Tunnel, running 9,270 feet beneath downtown Seattle from the Sodo neighborhood to South Lake Union. The most counterintuitive fact about this project is this. The tunnel opened on the 4th of February, 2019, nearly 4 years late, and the state of Washington still claims victory. The whole project cost $3.2 billion, which includes design, interchanges, street rebuilds, decommissioning of the old Battery Street Tunnel, and demolition of the Alaskan Way Viaduct. The $80 million tunnel boring machine Bertha was created for this project by Hitachi Zosen Corporation near Osaka, Japan. The 326-foot, 6,700-ton machine was disassembled into 40 pieces and shipped to Seattle, where it was reassembled in the launch pit near the south end of the future tunnel. From there, the record-breaking 57-5-foot diameter borer would move in 6 5-foot increments toward the north end. The 2-mile double-decker tunnel carries a section of State Route 99 under downtown Seattle, from Sodo in the south to South Lake Union in the north. Since the 2001 Nisqually earthquake, replacement of the Alaskan Way Viaduct had been a source of much political controversy. The promise was simple. Replace a crumbling, elevated highway with a modern underground corridor, remove the visual blight from Seattle's waterfront, and do it on a fixed-price contract that protected taxpayers from overruns. At the time, the tunnel was estimated to open to traffic at the end of 2015. Everything began to quietly break in December 2013. 3 forces converged to make Bertha possible and to make her failure almost inevitable. The first was political urgency. In 2009, after 8 years of public discussion and planning and several votes, the city of Seattle, the state of Washington, and the Port of Seattle agreed to build a deep-bore tunnel to replace the Alaskan Way Viaduct, which had long been considered a blight on the waterfront and was damaged in the 2001 Nisqually earthquake. The second was scale ambition with no peer precedent, the 57.5-foot diameter SR 99 TBM is more than double the size of the two 1-foot TBMs used to bore subway tunnels for Seattle's Sound Transit. The face area of the SR 99 TBM is 7 times as large as a typical TBM for subway tunnels, said Chris Dixon, project manager for STP. The third was a contract structure that transferred maximum risk to the contractor while minimizing state liability. The state maintained that under the design-build contract, the contractors were generally responsible for damage and delays, except for unforeseen soil conditions that weren't flagged in the state's geotechnical study. That final clause would become the most expensive sentence in Washington state transportation history. The result was a machine of record-breaking scale, deployed in geologically unpredictable glacial soils under a contractual arrangement that guaranteed no party would accept blame if anything went wrong. Here is what most people assume about Bertha's failure. They assume a buried pipe stopped a 7,982-ton machine. They are wrong, and the actual problem is far more specific and far more damning than that. WSDOT says other factors led the machine to overheat and the seals protecting the main bearing to become contaminated. The main bearing is the critical joint between the rotating cutterhead and the stationary body of the machine. Think of it as a giant wrist connecting the hand to the arm. It contains precision seals, lubrication systems, and hardened gears that must operate in a slurry of pressurized water, fine sand, and glacial debris. Insurance companies, which were also being sued, said in court papers the machine was underdimensioned for heavy Seattle soils, while manufacturer Hitachi Zosen of Japan said it operated perfectly. With every foot of diameter, the soil volumes, torque to spin the cutter, and the drill's own weight grow geometrically. At 57.5 feet wide, Bertha was operating at a scale no machine had been tested at, in ground conditions that were documented as high risk before a single ring was installed. Grit was discovered inside the seals of the cutter's rotary axle. When those seals failed, the bearing failed, and the machine was done. That sequence is the engineering record. The pipe was the spark. The seals were the powder head. Bertha remained stranded some 1,028 feet into its underground journey after overheating in December 2013. Crews had to excavate a 120-foot deep vault to rescue and repair the giant drill's front end, work that started in October 2014. That vault alone required an excavation operation of extraordinary complexity. Groundwater pumping beneath the stranded tunnel boring machine from wells as deep as 185 feet became the suspected cause of troubling soil settlement in the surrounding neighborhood. Seattle Public Utilities replaced a cast-iron, 20-inch diameter water main below Western Avenue after the soil sank 1¼ inches near the tunnel job site at a cost of $11.4 million. Then, when Bertha finally resumed digging in December 2015, she stopped again. After a brief stoppage due to the development of a sinkhole in a work area, tunneling resumed in February 2016 to complete the remainder of the drive. That incident happened the same day a Seattle Tunnel Partners barge listed while being loaded with tunnel muck alongside Terminal 46. The tilting barge dislodged at least 15 concrete pilings and spilled soil into Puget Sound. The rehook arrives here. Contractors had sought as much as $600 million above the $1.35 billion tunnel construction contract amount, which was the largest piece of the state's $3.3 billion project to replace Seattle's old Alaskan Way Viaduct and connecting streets. That is not the damning figure. The damning figure is this. STP sued its insurers for $80 million. It believed it was due on an insurance policy for which it paid a $25 million premium, and the insurers countersued STP and Hitachi, claiming the two had conspired to blame the steel well casing for the damage to Bertha, even though they knew that was not true. The insurer of the world's most expensive tunnel boring machine believed the machine's own builders and operators had agreed to frame a buried pipe for a failure they knew had other causes. That allegation was never proven. But it was put in court, in writing. The story became public in January 2014 when the Seattle Times reported that the steel pipe struck by Bertha had been placed there by WSDOT engineers to study groundwater and had been included in the plans provided to the contractor prior to the tunnel bid submission. In January 2014, the steel pipe was blamed for the tunnel stoppage. The Seattle Times reported the steel pipe struck by Bertha was put there by WSDOT engineers to study groundwater and included in plans provided to the contractor prior to tunnel bid submission. The question of who knew what and when sent every party to their lawyers. Fragments of the steel well casing struck in December 2013 and site early discernible because of Bertha's breakdown were stored as evidence at the construction site and subsequently went missing in 2014. Detailed journal entries kept by the tunnel contractor's deputy project manager between December 2013 and February 2014 also went missing. The pipe fragments were likely discarded into a recycling bin during an overnight job site cleanup in January or February 2014. The physical evidence for the contractor's central argument in a $600 million lawsuit had been thrown away. Judge Carol Murphy wrote in a ruling that Seattle Tunnel Partners consciously disregarded the importance of the lost 6 pipe fragments and 2 granite boulders. The first wave of legal claims followed immediately, and they multiplied. Pioneer Square building owner Brian Runberg knew his brick building at the foot of Yesler Way occupied the most precarious spot on the Highway 99 tunnel route. What he could not foresee was that construction noise, vibrations, and blight would linger outside his doorstep for 5 years. Runberg asked for compensation, but the Washington State Department of Transportation rejected his $364,475 damage claim. The state had earlier paid him $52,712 for repairs after brick mortar flaked onto the desks inside his architecture firm. He described a level of fatigue when it's gone 5 years. He claimed a further loss of $121,217 when he slashed his restaurant tenant's rent in half. The city of Seattle said STP, or the state, owed as much as $81 million for potential damage to underground utilities, sidewalks, and streets throughout Pioneer Square. WSDOT itself agreed to spend $20 million to seismically strengthen an old warehouse at 619 Western Avenue rather than demolish it before Bertha went underneath. Roby Russell, a nearby tenant whose law office walls were cracked during the groundwater episode, predicted landowners would file claims when the tunnel was done, based on his conversations with neighbors. The final legal word came in December 2019. STP requested up to $642 million during the lawsuit, but in the 2019 jury trial, Judge Carol Murphy of Thurston County Superior Court capped the potential amount at $300 million. Jurors not only denied STP, but ruled the companies must pay WSDOT $57.2 million in contract penalties for 867 days of delay, which grew with interest to $77.2 million while STP appealed. The Washington State Supreme Court ultimately turned down a hearing request from the contractors, leaving taxpayers off the hook for cost overruns. Everyone who could not prove their losses to a court's satisfaction absorbed them in silence. Maybe the defenders of this project are right. The tunnel is open. Traffic moves through it. The Alaskan Way Viaduct was demolished. The waterfront, by some accounts, is better. Consider, however, the case of Boston's Big Dig. Late at night, on the 10th of July, 2006. A car was driving eastbound on Boston's Interstate 90 connector tunnel when 15 panels from the tunnel's suspended concrete roof collapsed onto the vehicle, covering it instantly with 26 tons of concrete and steel. The driver survived, but the passenger was killed. The companies responsible for designing and building the collapsed tunnel faced both criminal and civil charges. They settled for $458 million with the state of Massachusetts in a criminal case, $16 million with the city of Boston to avoid manslaughter charges, and $28 million with the family of the victim in the civil case. Boston's failure, born of an adhesive anchor never designed for long-term overhead load, forced the industry to confront what happens when an innovation is deployed in a mega project without sufficient testing under real conditions. Seattle's Bertha presented the same logic at the level of machine scale, a device built to a diameter never attempted in comparable soils, deployed under a city with no margin for the failure mode that materialized. Maybe the darker possibility is this: no contract structure, no geotechnical study, and no machine specification can fully account for what lies beneath a city that has been sinking on its own fill soil for a century. The warning signs were in the data. The soil samples were taken. The sensors were attached to the buildings. And still, 80 feet below First Avenue, on the night of the 6th of December 2013, the largest tunnel boring machine ever built wound down to silence. Tonight, beneath Seattle's streets, the SR-99 tunnel carries 4 lanes of traffic through 9,270 feet of concrete rings, each one installed by a machine that cost more to repair than it did to build. The soil above Pioneer Square, where the ground sank 1¼ inches a decade ago, is still monitored, still settling, still carrying the weight of buildings that predate the automobile. And somewhere in a recycling bin that no longer exists are 6 fragments of steel pipe that might have explained everything.